You are at the turning point in your life, and you have to decide who you aspire to be. Ask yourself, are you interested in being the next leader of technology? Are you interested in artificial intelligence, machine learning, data science, big data analytics? Do you want to be the Einstein, the next Einstein who is going to change the world and solve all the real world problems? If your answer was yes to all the above things, you have found the right place. At UAH, you will learn how to solve real-world applications such as drug discovery problems as in COVID-19. You will learn how to use artificial intelligence and solve the drug discovery pipeline and make it much more faster so that we have a vaccine. You will learn how to use satellites, drones, and all the imagery that you collect from them to solve weather problems, predict hurricanes, detect different elements that you see from the space. You will learn how to solve cybersecurity applications, on how to secure your Internet of Things, IoT devices, smart grids, and all the other connected devices that we have, that we are using in our lives, and how to protect them from cyber attacks. And also, if you're interested in computer science and you want to create all those fun games that you thought was revolutionary in your social media network, such as creating your dog breed, find your spirit animal, look at whose celebrity you're close to, then UAH welcomes you. If you are ambitious, you are a student who want to scale new heights, UAH is the right place. We at Computer Science Big Data Analytics Lab, we want such inspiring, motivated students so that you can be the next pioneer in technology.
My name is Letha Etzkorn, and I'm the Associate Chair of the Computer Science Department here at UAH.
And I'm Mary Ellen Weiskopf. I'm the Undergraduate Program Coordinator. That means that I am familiar with what's going on in the undergraduate curriculum, and that's what we want to talk to you about today. I'm going to give you an overview of what you would be taking if you were a computer science major at UAH, and then Dr. Etzkorn will give you some of the details. First of all, everybody takes a certain number of general education requirements, and those are things like English and history and social sciences, things like that. Plus, for a computer science degree, you need a good bit of math. In addition to that, you're going to be learning good software development, how computers work, what are some of the theoretical foundations of computing, and then you have a chance to tailor your program to your own interests by the way you choose your electives. We have a 3-course sequence that is the coverage of programming. In addition to that, you will have some courses that introduce you to computer hardware. You'll get a little bit of assembly language in those classes. We have courses in how operating systems work, principles of programming languages, and a couple of theoretical computer science courses. And with the electives, you get to choose what areas you might like to specialize in, or maybe you just like to take a little bit in a lot of different areas. And so Dr. Etzkorn is going to tell you about a couple of areas of interest that we provide.
You're allowed to take electives in a lot of different areas, so you don't have to specialize in any one area. If you don't know what you want to take or what you want to do in computer science, you can try a lot of different areas. We have a pretty big footprint in the area of computer security, cybersecurity. We've got a course on network security, that's security of computer networks. We've got a course on mobile digital forensic. When you have a person who is being suspected of ill doing, for example, you can get hold of their disk drive or their flash drive, and you can analyze it and find out everything that person's ever done. The FBI is starting a big new forensics section in Huntsville on Redstone Arsenal. Another thing that we've gotten big into lately is data science, data mining, or you might call it artificial intelligence. It's the kind of thing where you analyze big sets of data to determine trends in the data. Okay, huge amount of need for that in industry, huge number of applications for that. For example, you can apply that to cybersecurity, where you can do intrusion detection systems that learn what real people, people who are legitimate users do on a system, such that they can detect when a person who is an illegitimate user, in other words a hacker, comes in and tries to get on the system. So that's one application of data science, data mining. We have several courses in that. We have a thing we call the entertainment computing concentration. It includes a course on artificial intelligence for games and simulation, an intro to video game design and programming. They're using the Unity game engine to teach that course. So when you come out of that course, you're able to build a video game. We've got a mobile computing apps course, so you can build games or any other kind of app on your iPhone or your Android phone. And then we've got advanced graphics courses and advanced game engine courses. Our entertainment computing gaming program also leads into modeling and simulation. There are tons and tons of jobs in modeling and simulation in what you call serious games. We teach the code behind. We teach all the stuff, all the code, all the fancy stuff behind a web page that makes it an active page, makes it do a lot of things. But people are also interested in pretty web pages. We have a collaboration going with the art department, graphic design portion of the art department. Our students can take a couple of courses in the graphic design, learning how to make pretty web pages, and then they come and take courses in our department on how to do all the fancy code, all the code behind, all the stuff to make them very powerful web pages. So you can try different things to see what you're interested in, or you can concentrate in one area or another, and then we have, like I said, we have several courses in lots of different areas.
We were talking about graduates programs, and one reason we talk about it at the beginning of your career is because we have something called the JUMP program. What JUMP is a program that lets you, in your last year or two of undergraduate school, take up to four courses that can apply to your undergraduate course program, but also be applicable to your graduate program. So you take 4 graduate courses and double count them. And I mention it to you now because admission to the program depends on you having good grades, and so it's important to keep your grades up as you go along. And this is just one of the things that I think makes the UAH an outstanding opportunity for students. Most of the students I know, by the time they graduate, if they want to have some sort of real-world experience, they have opportunities to have that. And whether it's through an internship or working part-time for a company, or going through the co-op program, which is an excellent program, the opportunities that you have are very widespread. There's so many organizations here in Huntsville that hire computer professionals and are anxious to get you as an undergraduate student so they can train you to be a useful employee when you graduate.
The UAH Gaming and Entertainment Computing concentration has been understandably popular with students. But you may be wondering, does the concentration prepare students for anything other than game development? Please be assured that it does, for 2 reasons. The first reason is that computer science students in the concentration complete all of the core computer science courses required for their degree, and therefore are well educated in general computer science. The second reason is more specific. My own specialty is modeling and simulation. I've been working in modeling and simulation research and development for over 30 years. The job prospects for computer science graduates who can work in modeling and simulation is excellent. Huntsville is home to many employers, both government and industry, who are eager to find computer science graduates who can work in modeling and simulation. What does modeling and simulation have to do with game development? The technology transfer between the 2 fields is substantial and growing, and skills acquired in one field can readily be applied in the other field. Let me show you some examples. Models of crowd movement provide a realistic environment for games and a way of testing pedestrian flow and evacuation in urban planning. Accurate models of flight dynamics provide a realistic experience for flight simulation gamers and an effective training environment for commercial pilots. Network interoperability protocols exchange data between players in multiplayer online games and between simulators and military tactics trainers. Important algorithms are used in both games and simulations. For example, the A-star pathfinding algorithm is used to plan routes for both characters in games and vehicles in traffic simulations. There are many more examples. The bottom line is that the gaming concentration is an excellent choice for UAH students who are interested in developing skills that would also apply in modeling and simulation.
Entertainment computing is an exciting subtrack within the computer science curriculum that'll give you the technical know-how and academic skills to dissect, analyze, and create the multimedia that forms the beating heart of the modern internet. Start by bringing your own favorite games, music, and videos to our multimedia analysis classes. Advance your skills by learning game development, artificial intelligence, and mobile app creation. Finish by performing internationally published research on cutting-edge topics such as gesture recognition, machine learning, gamification, and computer graphics. The Entertainment Computing track is ready and waiting to supercharge your involvement with the media that will shape the future.
A little bit about myself. I'm an assistant professor in the Department of Computer Science at UAH, and I joined UAH in fall of 2018. My contact is there on the screen. If you want to contact me to know more about my research after looking at this video, feel free to email me. My research focus is on the applications of artificial intelligence for operations in highly contested environments. And in a nutshell, I mean, it's all about cybersecurity applications in environments where you have active adversaries trying to create problems for you. Okay? And that might be your daily real-life civilian setting, or it might be examples where you have applications in the military. Okay? My teaching interests are mostly in network security, forensics, and I'm also the one who started teaching hacking for defense at the University of Alabama in Huntsville. As you may or may not know, hacking for defense is a teaching paradigm where we introduce real-world problems for the Department of Defense in the class, and the students taking the course are required to solve one of these problems at the term project. I'm also interested in malware analysis, and something that I've not written in this slide is quantum computing, that something that I've started doing recently. My current funding is more than $1 million, and it's mostly funded from Air Force Research Labs, Munitions Directorate, and the National Institute of Justice. A little bit about my research. So, till date, I have worked primarily with networked weapon systems, and it's the research is mostly about security of network weapon systems. Okay, and as you might know, as we are getting into 2020, 2021, and so on, the scenario in the battlefield is changing rapidly. So we have artificial intelligence, which is it's something that is coming up really, really fast, and it's becoming a de facto part of our lives. You have artificial intelligence on your phone, you have artificial intelligence on your computer, you use and interact with AI day in and day out. And it's natural that artificial intelligence is going to spill over to the battlefield. Now, when we are using AI in the battlefield, it's a very, very different scenario. It's a very, very different ballgame, because artificial intelligence is not like a silver bullet which can do everything. Right? I mean, you have scenarios where AI can work well, you have scenarios where AI can make mistakes. However, when you are in the battlefield, when you are using AI, you have to make sure that the mistakes that it makes are very, very less. Okay? So you have to really make sure that it's very accurate. Because think about it, if you have a flying weapon, say a missile, which is supposed to hit a target, okay, and you have an AI controlled guidance system, and if it hits the location where it's supposed to, but is off by a couple of meters, it might mean life and death for a lot of people. Okay. The other option would be to think about target detection. So suppose you want a missile to go and hit a tank. Okay. However, the system, when it does an automatic target detection, instead of correctly identifying a school bus as a school bus, it identifies the school bus as a tank. Think about what would happen. Okay? So when we are using artificial intelligence in the battlefield, it's way more intensive than when we use artificial intelligence in our real life civilian. Even for driving a car, when you are using artificial intelligence, is not as intensive as if you were using artificial intelligence for flying a missile to its target. So in case of network weapon systems, my research has touched areas of spectrum usage. So for example, we want to make sure that the communication that is happening is automated, but the available spectrum for doing the communication is fully used. We want to minimize power requirements. Okay, so because you cannot have a super powered computer sitting on a missile, because it's firstly going to blow up. Secondly, you do not have that kind of real estate on a missile. So any kind of computing that you need to do for doing AI on these weapon systems, you need to make sure that they are low power. Okay? We want to maximize environmental awareness. So for example, a flying object, you can think about a missile or a drone, it needs to be aware of its surroundings. Okay, and everything needs to be done through sensors. So you have cameras, you have radios, you have sonars, radars on the systems, and it's collecting data from all these different sensors. You need to merge this data together, and you need to, after merging the data, you need to process the data and use AI to literally situate yourself in the environment, to know where I am, where I'm going, and also make decisions, right? For example, should I go right, should I go left, or should I go straight? Okay, or if you have, the target that starts moving, what do you do? Okay, so we need to be aware of our environment, and we also need to maximize resilience to attack, because most of my work has been in environments where you have active adversaries, adversaries who are really intent on making sure that you do not achieve your goal, you do not achieve your objective. Okay, and so these systems need to be resilient to adversarial attacks. Okay, so if someone asks me like, okay, after these things, what is your research? Okay, I will say in one sentence that it's adversarial learning in highly contested environments for network weapon systems and other applications. Okay. Now, one of the goals of my research has been autonomy, right? And I want it to be robust in the sense that I want it to be resilient to failures, resilient to adversarial attacks. Okay, and I also want it to be cooperative in the sense that weapon systems or any of these, you can have drones. They do not operate in vacuum. There are other systems that are assisting them. So, for example, when you have a drone flying in the air, you might have ground stations which are also helping it, right? So these need to communicate and cooperate with each other. Okay, so that's one example where you would need cooperation. Okay, and I want to essentially make sure that we can use AI for building these autonomous systems which are robust. Okay, and this robustness is built in through the cooperative nature of the interactions among these systems, and also being agnostic to presence of adversaries. Okay? And they also are opportunistic and also compete with each other, so that they would be situationally aware and take decisions so as to make sure that their goals are met as soon as possible. The overall tool that I use is artificial intelligence, adversarial learning, cooperative and distributed learning frameworks. That is, in a nutshell, what I use. Test beds, my research really works with real-world data. So we do a lot of data collection. We use radios, which are called software-defined radios, and these are programmable radios, which you can program to do certain things. And we use these radios for collecting real-world data, and then we use this data for our research. And these, our radios are mounted on drones, for example, cars, and we actually drive around with these radios mounted on the cars, collecting data in a real-world setting. For example, one of the work that I did was trying to localize yourself, find your position using FM. Okay, so FM radio we all listen to, but our question was, okay, what if GPS is not there and you want to position yourself without using GPS? Can I do that using FM? Okay, and for doing that, we had this radio mounted on a car, and we were driving around the interstate, collecting data so that we could learn how to position ourselves in real time as we were moving without GPS. and we showed that we can actually do that using these radios. Okay, so that's an example of the kind of work that we do. Okay, so it's all real-world data, real-world transmissions, and you can think about this whole thing in the framework of cybersecurity. So when we think about cybersecurity, we usually think about computer systems and hacking and so on. But cybersecurity has a much general, much bigger picture. Okay? And my research in cybersecurity essentially addresses that much bigger picture, not just computer systems. Okay? It has a much wider application. And the tools that we use are essentially artificial intelligence, because we believe that the next generation of cybersecurity systems are going to be based on AI. Be it your antivirus that you use on your system, be it a drone that's flying in the sky and taking pictures. AI is going to power all these things. And that's where our research comes. Hopefully I've given you quick overview of what we do. I would love to hear from you. If you are one of the people who are listening to this video and think that you are interested in what I do, please feel free to send me an email and we can have a conversation. Thank you.